Hi there. Now for this question, we're told that the adult population of a town is 25,000 at the end of year 1. And a model predicts that the adult population of the town will increase by 3% each year, forming a geometric sequence. And we've got to show for the first part that the predicted adult population at the end of year 2 is 25,750 for 1 mark. So if you'd like to try this, just give you a moment to pause the video. Okay, welcome back then if you had a go. Well, for this first part, it's only worth 1 mark, so it should be very easy, and indeed it is. All I'm just going to do though is just put an intro, and that is the population at the end of year 2. And what's happening is, because it's going up by 3% each year, what we can do is just say we're going to increase this by 3%, so the multiplying factor is going to be 103%, or 103 divided by 100, or 1.03. So all I've got to do is take my 25,000 and multiply it by the equivalent of 103%, which is either 103 over 100 or 1.03. And if you do that, you end up with 25,750. And that's what we had to show. Okay, now in the part B, it says write down the common ratio of the geometric sequence for 1 mark. So again, give you a moment just to try that if you'd like to pause the video. Okay, welcome back then if you had a go for that one. Well, what we're doing is multiplying each term by 1.03. If I wanted to get the population for year 3, I'd just multiply this by 1.03. So all the time I'm multiplying by 1.03. So we call that common ratio R, and R would be equal to 1.03 then. Now for the next part, we're told that the model predicts that year N will be the first year in which the adult population of the town exceeds 40,000. And we've got to show that n-1 times the log of 1.03 is greater than the log of 1.6 for 3 marks. And then we've got to go on to find the value of n for 2 marks. So if you'd like to have a go at this part now, just give you a moment to pause the video. Okay, welcome back then if you had a go. So what we're doing here is working out the nth term of the sequence. And you should be familiar with the fact that if you have a geometric sequence, the first term is A, second term is AR, third term AR squared, and so on, the nth term is always given by AR to the power n-1. So for this part of the question, part C, let's just put that there, we're told then that the nth term after year n, it's going to be 40,000, or it's got to be greater than 40,000. So the nth term will be A, the first term of the sequence, which is going to be 25,000. So we've got 25,000 multiplied by the common ratio, that would be 1.03, raised to the power n-1, has got to be greater than 40,000. So it's just a question now of rearranging this and showing that we get this particular inequality. Well, I can see that if we just divide both sides now by 25,000, we therefore have 1.03 to the power n-1. Don't make the mistake of thinking this is 25,000 times 1.03, then raised to the power n-1. Okay, So if I divide both sides by 25,000, we're going to have 40,000 divided by 25,000, which turns out to be 1.6. Now, because I'm trying to find the unknown here, which is a power, we need to introduce logs to this. So I'm going to take logs to base 10 to both sides. So therefore we get the log of 1.03 to the power n minus 1, and that's going to be greater than the log of 1.6. So the logs here are in base 10, okay? Now, there's a rule that you should be familiar with when you've got powers, okay, over a log. That is that you can bring the power out to the front of the log. So this is the same as saying n minus 1 multiplied by the log of 1.03. And this will be greater than the log of 1.6. And that is what we had to show for the 3 marks. Now in part D, we've just got to continue on and find the value of n. So at this point, if you'd like to pause the video, I'll just give you a moment to do that. Okay, welcome back then if you carried on to try and find the value of n. So what you need to do here is remove the log of 1.03, and to do that we would divide both sides by the log of 1.03. So that's going to give us n minus 1, and this will be greater than the log of 1.6 divided by the log of 1.03. You have to be very careful when you're working, by the way, with inequalities and logs. If this was the log of a number less than 1, this quantity would be a negative value. And remember, when you divide by a log that would be less than 1, a negative value, you must always change the inequality, reverse its direction. So that's not going to be the case here, but there are times when I've known that to happen. It catches people out. Okay, well, moving on, if you work this out on your calculator, you find that that comes to 15.9006, and so on. And then if I add 1 to both sides, we end up with n being greater than 16.9006, okay, and so on. So what year must we be talking about here? What's the first year in which the population exceeds 40,000? Well, it's got to be the least value of n, and n's got to be an integer. So the smallest integer greater than 16.9 has to be 17. So therefore n must equal 17. Okay?